All right, everybody, we are going to try to go ahead and wrap up this first section here, 6.1, on integration by parts that we've been working through here. So this example, we're going to do one, this is similar to the one we left off with in the, I think the previous example, okay, and we said that integration by parts, here's that formula, okay, u dv equals uv minus v du. That formula is not something that you guys need to have memorized or anything, okay, you just need to know how to use it here. Okay, so we've got two factors we're multiplying together. We want to choose the easier or simpler one of the two to be u. That would be x plus 1. We want to choose the more complicated of the two factors as the dv. That would be the 2 minus 1 quantity cubed, and dx always goes with that. Okay, we've been talking these last few days about taking the derivative of u and integrating dv, and this helps us get what du is, which in this example would be a 1, and then we bring the dx over, and then we integrate both sides here to get what v is. Okay, and in the last example, whoops, there should be an integral sign here, we learned that if what we're integrating is a quantity, well then that's going to require us to integrate that piece by substitution, okay? So we might have to actually integrate by substitution. And we said instead of using u's, we were going to go ahead and use a different variable so we don't get confused here. We're going to use a p. Okay, we're going to let p equal this quantity 2x minus 1. Okay, and then we're going to take the derivative of that. So dp equals 2. And then we bring the dx over. Okay, so these are our substitutions here. All right, and so I'm going to come back over here to this. I'm going to take the 2x minus 1 out, put a p in its place, and then I'm after kind of comparing what is everything extra here with what I'm saying dp equals, and I see that I'm going to have to insert a 2 there and then a 1/2 out here. Okay, so that's going to make this a 1/2 integrate p cubed, and then I can put dp there, okay, because now this is matching all of that. Okay, once you do that, don't forget we have not integrated this right side yet here. Okay, so we did all of that so that we can integrate. So let's go ahead and integrate. We've got the 1/2. That's going to make this p to the 4th, 1/4, and we get 1/8 p to the 1/4. We're going to swap that out for 2x minus 1. Okay, I keep forgetting here to circle these pieces as I find them, but there's the v, this is the dv, here's the u, there's the du, okay, and you know, doing that was really step 2, okay. Step 3 is where we actually make these substitutions then into the integration by parts formula. Left side is just original problem, those two pieces multiplied together. Okay, and then this piece right here are these two pieces multiplied together. Okay, and I'm going to put the 1/8 all the way in front. Okay, minus, then this part is these two pieces multiplied together. Okay, so that would be this part right here, and I put the dx after it because dx is what du equals. There's a du right here, so I put that right over here. Okay, and then we look at this and we say, okay, now we need to figure out how can we integrate this part right there. Okay, well, it's going to require us to integrate by substitution, which we already have that listed up here. Okay, so we're going to come back to this. Copy this part in front down. Okay, I'm going to swap the 2x minus 1 out for a p. And once I do that, I'm going to compare, okay, what's dp equal to? What's equal to a 2 dx? Oops, I'm sorry, I wrote dp right there. It's equal to a 2 dx. I don't have a 2 here. So I'm going to go ahead and insert a 2 and put a 1/2 in front, and now this matches that, and so in the next step I can swap that out and put a dp in for the 2 dx. Okay, while I'm at it here, well, I'll go ahead and write this down here. Okay, there we go. Okay, so I'm going to go ahead and scroll this. Okay, we should be good to go with integrating here. Okay, so we'll go ahead and integrate this now. I'm going to combine these and make this a 1/16. I'm adding 1 to the exponent, multiplying in front by the reciprocal. This is where my plus c comes in. Okay, and then I would want to multiply those together. Okay, 1/16 times 1/5 is 1/80th, and let's take the p out, put 2x minus 1 in its place, and then over here on this side, I'm just labeling this what the original problem was. Okay, and then this would be our answer. Okay, all this right here. Okay, that was similar to the one we had done previously. Okay, those are pretty involved here. Okay, so the last example that we're looking at to kind of close out this section in this notes page, it's a word problem. Okay, not quite as involved as that one that we just looked at, but the idea with this word problem is it's looking at something called a continuous stream of income, and this is what people generally try to do whenever they have retirement. They want to invest money now when they're younger, so that later they can live off of the interest that's created by that amount of money. And so when you see the phrase present value, that means money that should be invested now. Okay, money that should be invested now. Okay. So there's this formula here that you do not need to memorize, but there's lots of variables to it. Here's what each of the different variables represent. Okay, this C of T is the rate, like how much money do you want to be able to pull off of your nest egg every year? Okay, so that's what this C of T is. The little t is the number of years from now, and that's right here in the exponent. Okay, the capital T is the years that you want it to continually have that interest rate, and the R is the actual interest rate that needs to be as a decimal. Okay, so we're going to use that formula in this next example, and I rewrote it at the top here so that we don't have to flip back to the next page. Okay, but we need to take all the numbers in this problem and plug it into the appropriate place into the formula, and then we can work on how to integrate it. Because the question is, find out how much money you should be putting in now if you want to generate $2 million per year T years from now. Okay, so I'm just going to abbreviate PV for present value. Okay, it says it's going to have this continuous stream of income for the next 5 years. Okay, so we're put 0, 5 is what we're putting in for the capital T. The rate for this C of T here is 2T. You'll see there's an E in the formula after that. You notice in the exponent there's a negative R. Okay, so we're going to put negative, and then we want to always do the interest rate as a decimal, 0.10. Okay, and then the lowercase t stays as a t. That's like your variable x, and then it's up to us. We got to make sure we put the dt there. Okay, so we want to think here, what are we studying in this section? We're studying integration by parts. Okay, and so the integration by parts formula, that's the right side. Oh, I didn't write that very nicely at all. I'm sorry. Okay, so we're integrating the original problem. Okay, and that's what we get there. Okay, so let's go ahead and see if we can kind of go through these steps here. Okay, so first part, we're going to pick something for u. We're going to pick something for dv. Okay, I want to pick the simpler of the two factors. That would be the 2t. Okay, the one that's a little bit more complicated, that's going to be my dv. That's going to have the dt attached. Okay, second step, we're taking the derivative of u. I'm going to have just a 2 on this side. I'm going to swing, it'll be a dt that I'll be swinging over to that side. And then here, I'm going to integrate both sides of this formula here. Okay, that gives me just a v. Now, when you go to integrate this, this does not require integrating by substitution. Remember, if your exponent is first degree, which it is in this example, we can just integrate this outright. Okay, we copy down the original, we would multiply in front by the reciprocal. If we typed in 1 divided by negative 0.10, we end up getting negative 10. Okay, So that's like our V. I'm going to label it on that side here. Okay, I'm going to circle all 4 of my pieces here. Okay, this was the original dV. And this is what we said V was. Okay, and then we can go ahead and do step 3, which is to make our substitutions here into the integration by parts formula. Okay, this is the original problem. Okay, and then he said there's a little bit of a pattern here. Then it goes kind of catty corner here. So I'm doing, let's see here. That's going to be, we'll just write it like this for now. And I'll combine those together here in a second. There's U times V minus integrating V du. Okay, that second part here where I was getting that from was then these two together. Okay, all right, I've got some things here that just need cleaned up just a tad. Okay, so I'm going to combine some things. This will be negative 20t to the negative 0.10t. Nothing more I can do with that. Okay, I got 2 negatives here. I'm going to combine that into a positive. I also have this 10 and I have this 2. I'm going to make that a 20. Okay, whether you have the 20 in front of the integral sign or like to the left or to the right of it, that doesn't matter. Okay, but let's see what we have to integrate here. Okay, well this is just asking us to integrate e to the negative 0.10t, which is something we already did up here earlier. So we should easily be able to do that. Okay, that's just going to be copy down the original, multiply in front by the reciprocal. Now I'm not going to put the plus c. In fact, probably what I should have done, since this was a definite integral here, is when I set this up, I should have put maybe a 0 and a 5. But that actually gets applied to all of this here. So let me clean this up here. We got 20 divided by negative 0.10. Okay, so this is going to be negative 200. Okay, and I'm getting that from combining that together. Okay, on my calculator here. Okay, and I got this vertical bar, and you guys know how this works then. You know, you just make the substitutions in, plug in a 5 in. Now these are going in for the t's. Okay, so I'm going to 5 here, 5 there, 5 here, and be very careful with this. Just because you're plugging zeros in doesn't mean it's going to wipe all this out. Okay, in fact, you're going to see that it does wipe this out, but over here this part turns into a 1, and so I still have like a plus 200 on the end there. And I don't have this answer written down in front of me, and I'm very sorry about that. But whatever this amount is, you guys can type that into your calculator. That's what the present value should be. That's how much money they should be putting in now if they're wanting to get the outcomes that are listed up above here in the problem. Okay. Okay, I will say at the very bottom here, we're just going to skip example E. At the very bottom, this kind of gives you a really nice summary of sort of how to choose, you know, what U would be in each scenario, and then, you know, what dV would be. Okay, and you can see that if there's an E, usually we're saving that for dV. Remember we said if there's a natural log, that has to be what you pick for U, because we can only take the derivative of natural log right now. And when given 2 quantities, the more complicated of the 2 is typically your dV. Okay, just a few problems for you to try again here tonight. You can see what that assignment is that was posted on the weekly agenda, also on Google Classroom. And again, reach out if you guys have questions. Okay, we'll talk to you guys later.